I've been called worse. All right, so this is 3-2 for the 8th graders. Page 171. So this is just a little bit more of what you were taught yesterday, and after looking at the quiz results briefly, you guys have a pretty good grasp of, what are functions. So this is, well, let me ask you guys a question here. If I had a graph and I had a line that went like this and another one that went like this, which one of those is a proportional relationship, Miss Olson? The one going through the origin. Okay, and what else is required for a proportional relationship? Yeah, what do you think? Miss Curtis? It's got to be a straight line. Okay, it's got to be a straight line. So this one is not a proportional relationship, the blue one, because it doesn't go through the origin, but it is a straight line. And so you're going to be looking at graphs today that have lines that look like this. Okay?
Oh my God.
So when you, listen, when you have graphs with a line like that, it is not a linear equation, because linear means line, it's not straight. It's also obviously not a proportional relationship. So let's look at example 1 really quick here. They've got some terms that you might want to pay attention to here. So it says represent a linear function. You know what that would look like. With an equation and a graph. So they've got a 10,000 gallon swimming pool needs to be emptied. Exactly 2,000 gallons have already been pumped out of the pool into this tanker. How can you determine how long it will take to pump all of the water into the tanker, from the pool into the tanker? All right, so they show you one way here. Here's the total that needs to be pumped. They've already pumped 2,000, and they're telling us they're pumping out 720 gallons. I think that was per hour. Yep, it says it right up there, per hour. So it says the amount of water that's already been pumped out is the initial value, or the y-intercept. And so you can see they represented it right there at 2,000. And the amount of water being pumped every hour is the rate of change, or the slope, or the constant. Okay? And so we have a straight line here. It's a linear function if it's a straight line. It's not a proportional relationship because it doesn't start or go through the origin, but it is a linear function. So the triad I already filled that out for you. It says as the pump is pumping water, the amount of water in the pool decreases. Makes sense. At a constant rate. It says complete the statements below, then graph the function. So the amount of water remaining in the pool is 8,000 because it was originally 10. And we're starting with 2,000 already taken out of the pool. The amount of water pumped each hour is 720 gallons. And so the equation is 0 equals a negative 720 t, t represents time, plus 8,000, because that's what's left. And then to convince me, it says, how is the rate of change of this function different from that in example 1? Well, you can just look at the two graphs and see the difference. This is a negative slope. And this one right here that they had for example 1 is a positive slope. And so I just put down the rate of change is negative for the triad, bottom of page 172. Let's look at example 2. It says represent a nonlinear function with a graph. So a nonlinear means it's not going to be a straight line. And you can just glance at the graph right here, and you guys can see that. It says make a table that relates the different side lengths and areas, because they're asking you, how can you determine whether a relationship between the side length and an area is a function? So here they have a square. You guys all know the formula to find the area of a square. It's simply length times width, or you're multiplying two sides. And so if the length is 0, the area is 0. If the length is 1, the area is 1, because you're squaring it. If the length of a square is 2 inches, the area is 4, length times width. If it's 3, it's 9, 4, 16, 5, 25. I think you guys get that. And then it says for each input value, a unique output value. So the relationship, this is a function. Okay, it is a function because there's one input and to one output. Okay. But it's a nonlinear function. It's a curved line. So the graph of this function is not a straight line. It's a nonlinear function. I think that's pretty self-explanatory. Let's look at example 3 here. Identify functions from graphs. Determine whether each graph represents a function. So each of these, the first two here, it says each of these graphs represent a function because each x value corresponds to exactly one y value. So they're functions. But this one here, this graph does not represent a function because each x value does not correspond to exactly one y value. And they gave us an example here. For example, the x value -2, which would be right here. Okay, and then if we went straight up from -2, we're going to come across two y values, 1 and 5. So that's not a function. Look at the try it here. I actually already kind of did this with you guys at the very beginning. It says draw a graph that represents a linear function. What equation represents the function? We already kind of talked about this here. You can see that there's one line that's a proportional relationship, one line that's a linear function, and one line is a nonlinear function. Mr. Mason, which line, if you can see it from over there, we've got a blue, purple, and orange. Which line is just a linear function?
Purple.
Well, okay, you're right. That is a linear function, but it's also a proportional relationship. So the blue one, so I couldn't say you're wrong. The blue one is a linear relationship. The purple one is a proportional relationship because it's straight and going through the origin. And obviously the orange one is not linear. So go ahead and put up 100 points. All right, let's turn the page here. This is on 174. Key concept. Number 1, what's it say to do? It says, what are the different representations of a function? And basically, we're talking about a table and a graph. 2 and 3 I showed you earlier. Number 2, it says, how can you use a graph to determine that a relationship is not a function? Okay, and they're talking about a graph. There will be more than one y value for at least one of the x values. And number 3, it says, must the ordered pairs of a function be connected by a straight line or a curve on a graph? No. As long as there's one output value is assigned to each input value. Okay. Number 4, circle that. It says each week Darlene tracks the number of party hats that her company has in stock. The table shows the weekly stock. And the question is the relationship a linear function? Use the graphs. In other words, I want you to graph this chart on here. Is the relationship a linear function? Use the graph below to support your answer. So go ahead and graph it. You'll be able to tell if it's a linear relationship or not. Number 5, scratch that out. Not worried about it. Number 6 and 7.
6, 7. Sorry.
Explain whether each graph represents a function. So answer number 6 for you here. Yes, there's one y value for each x value. So number 6 is a function. And then you need to answer the same question for number 7 here. Is this a function? Number 8, A and B, circle those. It says graph the ordered pairs from the table. So you're going to graph them right here. And then the question is the relation a function? And yes, I want you to explain. You can explain it in a sentence. Number 9, it says relationship between the number of hexagons x. So this is the number of hexagons. And the perimeter of the figure they form, y, is shown on a graph. Is the perimeter of a figure a function of the number of hexagons? And I answered that one for you. Yes. Each number of hexagon results in exactly one perimeter. Again, the answer is yes. Each number of hexagons results in exactly one perimeter. Number 10, circle that and underline explain, because I do want you to explain it. Do the ordered pairs plotted in the graph below represent a function? You can see several all over the place here. Page 176. Number 11, A and B, do those. Train leaves the station at time t equals 0, traveling at a constant speed. The train travels 360 kilometers in 3 hours. It says write a function that relates the distance traveled, d, to the time.
Wait, don't do B.
No, I meant to underline it. I do want you to do both of those. And then B, graph the function and tell whether it's a linear function or a nonlinear function. 12, higher order thinking. It says tell whether each graph is a function and justify your answer. So you're either going to put circle yes or no, or put yes or no above graph A and graph B, and then justify your answer in here. Okay? Pretty easy to justify your answer. Number 13, circle that one and fill out those 3 boxes. Part B is the relation of function. Just put yes or no. You don't need to explain. And then they ask, is it a linear function or a non-linear function? If the answer is yes. You should be able to tell the difference between a linear and a non-linear function now. 14 here, they gave us an equation, slope-intercept form, y equals x plus b. Let me pull a stick here, see if anybody remembers here. Mr. Harsh, what's that 3 represent in that equation right there?
The y-intercept.
Yeah, the y-intercept. Very good. Put up 100 points. Let's see here. Mr. Scroggins, the 3 over 2, what does that represent?
The rate of change.
Rate of change or slope. Okay, good. Good. 100 points. All right, and then fill out those 4 values for number 14. And that's it. You guys are out of here in about 10 minutes, so you got plenty of time to work on this.